Okay, good morning, everyone. Thank you for coming. This is the HPC Big Data and Data Science Dev Room, co-organized by myself, Kenneth, and Roman, who just arrived. And our first speaker for today is Kenneth, and he's going to tell us how to install software for scientists on a multi-user HPC system. Please.
All right, thank you, Vasil. What I'm going to do this morning, first of all, thank you all for being here this early. I'm sure you had too much beer last evening, so thanks a lot for coming. What I want to do is compare 5 different tools to get scientific software installed on supercomputers, so these multi-user high-performance computing systems. So first of all, I want to look at the title a bit. So installing software for scientists, so this can be quite challenging. Scientific software has its quirks. It's very different from normal FOSS software where you can just run, configure, make, install, and has a man page and everything is nicely documented. That's not the case with scientific software. It's very, very different. Good software engineering practices are rather rare in my experience in scientific software. So the installation procedure is very non-standard. You have to figure things out from scratch, like for every separate application almost. Dependency hell happens here too. So these are scientists writing software. And the quote, I don't know where I got this quote, but if we would know what we are doing, it wouldn't be called research. So that's what scientists do. So they mostly care about the science. They don't really care that much about the software. They just want to get the science done, and they need to write software to get that done. So most of these people are not trained software engineers or system administrators. They just figure things out by themselves mostly, and if it somehow works, they're already quite happy. And also, on the flip side, not every scientist develops their own software. Sometimes they just want to use software that other scientists develop, and they want to make it easily accessible to them. So they don't want to install or compile it themselves. They barely know what a compiler is. They just want to get the thing working. The supercomputing aspect, so the multi-user high-performance computing systems, these are very different from a normal laptop in several ways, both in good and in bad ways. Of course, the main thing about supercomputers is that you get a lot of performance, a lot of parallelism out of these things. They can do a lot at the same time. But also in bad ways, they are very different. They're not that easy to use, especially not for scientists who, most scientists have never seen a terminal up close. And then you give them this black window with only letters and you tell them you don't need your mouse anymore. People get confused. There's also a wide variety of users. There's biologists, chemists, people doing like history studies of old newspapers and everything in between. So you need a lot of different software, very different software. You need also multiple versions because some people want to use OpenFOAM 4, some people want to use OpenFOAM Extend, and there's lots of variants of the same thing and in ways that are important to them. So you have to have everything installed. And typically, and there's other ways of doing this, but on a lot of systems, once you install software, it stays there as long as the system is alive. So scientists write papers, and 2 years later, they want to revisit the paper, or they end up writing a PhD that includes that paper, and you want to redo some of the runs, and hopefully with the same software, or at least as close as possible. And of course, performance is very important on supercomputers. If you buy this big expensive hardware with a really good expensive network, you also want to actually use it properly and get the most out of the system. So you don't want, for individual scientists, it's good that their runs are 10% faster with a little bit of effort. But for the administrators of the system, 10% is huge because that's 10% more science, right? So that's really what you want to aim for. So some disclaimers here. I'm doing a comparison between 5 different tools, but I'm certainly biased. So I'm the lead developer of one of these. I tried to make this a very objective comparison. I really tried hard to do that, and I hope you'll agree with me that that sort of worked. I'm very familiar with EasyBuild. The other 4, not so much, but I spent hours in the last couple of weeks playing with these tools, reading the documentation, installing software with them to try and familiarize myself with the tools. And yeah, that was a lot of time I spent since last Christmas on this. There's certainly personal bias still there, but I try to minimize it. And I sent my draft presentation to like the people behind these tools, like Todd, who's giving the next talk on SPAC, gave some feedback, Ludovic and the GUIX community. So all these people, I got some feedback, and basically all tools are covered. So I'm not going to tell any serious lies anywhere unless they missed it in the draft. So yeah, that was my attempt to make it very objective. All right. So I only have 20 minutes, so I have to rush a bit. So I'll do 30-second introductions of each, and I'll do them alphabetically. So conda is a tool that works on Linux, macOS, and Windows, so it's cross-platform. It's implemented in Python. This is really targeted towards end users, towards scientists. So it's very easy to install software with conda. Just do conda install something, and it goes and does its magic. Basically what it does, it pulls in binary packages, so pre-built packages from the Anaconda cloud, or whatever they call it. This used to be Python specific, but they have now support for C, C++, Fortran, R, basically anything out there, so it's no longer Python specific. The packages themselves are written in YAML, so YAML configuration format, together with a build script, so a shell or a bat, depending on the OS. You can build packages with conda build, which is typically not what users do, so this is what the people that prepare the packages do. And they're hosted on GitHub and all that stuff. They support about 3,500 different software packages. And most of these, or a lot of these, are scientific software. EasyBuild is pretty different compared to conda. It only mostly works on Linux, so it's very focused on supercomputers. It sort of works on macOS, but not really. We never tested there. It's definitely not a target platform. It also works on Cray supercomputers. These are different enough from Linux that it's worth mentioning that. It's also implemented in Python. This one is mainly targeted to support teams of supercomputers. So people that get install requests from scientists have to install the software and then give it back to the scientists. So not people installing software for themselves, and that's an important difference. EasyBuild builds everything from source, so it compiles everything from source. There's no binary packages that it pulls from somewhere. And one of the key things about EasyBuild is trying to get good performance for the installation. So it targets the hardware that you're installing the software for. And you'll see that coming back in the talk. Let's see, it has these easyconfig files as recipes, and it has Python modules, Python scripts that have all the logic to install the software. What else? It generates these module files because that's being used on pretty much all supercomputers out there. So people know this environment, and it makes it relatively easy for the scientists to just access the software. We have reasonably good support for site-specific customizations to the installations and keeping track of that. And today we support about a little bit over 2,000 different software packages. Then Nix, this is again very different from the other two. Cross-platform, well, at least on Linux and Mac OS, so no Windows. Implemented in C++ and the Nix custom DSL they have. The tagline, it's a purely functional package manager, so it tries to provide very reproducible builds of software, so it's very focused on that. There's an operating system that uses the Nix package manager as well, so don't confuse these two. It's two totally different things. You can use Nix on a traditional Linux system. You don't need to use NixOS if you don't want to. Very strong focus on reproducibility of compilations, even down to bitwise reproducibility, so getting the exact same binary on two different systems through Nix if you just ask it to do the same installation. And they do pretty crazy stuff like resetting timestamps to try and get to this bitwise reproducibility. So they're very focused on this. Support atomic upgrades of packages and rollbacks. By default, it also downloads binary packages, and if it can't find binary packages, it will build from source. So that's not, with conda, it will just only install binaries, while Nix will build from source if it has to. It has multi-user support as well, so it uses the Nix DSL for the package recipes. And this has over 13,000 different software packages supported, and that's not counting the 12,000 Haskell packages, so this is huge. of course, a lot of this is not scientific software. This is way broader than scientific software. Nix was not initially targeted at scientific software at all. Then there's Geeks, or Geeks HPC. There's a very good blog on using Geeks in an HPC context. That's mostly Ludovic and Ricardo and Piotr who write the stuff. Very good blog posts. So they're trying to explain how Geeks can be used in this context, where it has a lot of features that make it really make sense in this context. This is GNU Linux only, implemented in a combination of Scheme and C++. In my view, this is mostly targeted to system administrators and experienced end users. So I don't think you would give this to, let's say, a normal scientist. Maybe in the future you could. The design is fairly similar to Nix. It also has the Geeks SD distribution. It works on GNU Herd if you want to use that. You can. Very strong focus on reproducibility. It only supports free software. That's actually not really true, but it has some focus on that. Same upgrades and rollbacks as Nix does, and over 6,500 packages. And then SPAC is the last one in a row. Also sort of cross-platform, Linux, macOS, and Cray. Also implemented in Python. In my view, and I know Todd disagrees with this, it's mostly targeted towards software developers of big scientific software. So they need to juggle lots of dependencies, and it has a lot of flexibility for that. It's similar to EasyBuild in some ways, but different in many other ways. One of the main big differences is the flexibility it gives you to juggle dependencies. So you can do very cool stuff like this. You can tell SPAC, install MPI leaks, a particular version, with a particular compiler, and this dependency I want it locked to this particular version. And then everything else that it needs, SPAC will figure out by itself. So that's certainly quite different from what EasyBuild does. All right, so the project comparison, I want to fill in this table basically, compare all of these aspects, and I have this star rating system, and the colors are pretty straightforward. So releases, I'll speed up a little bit here to avoid going out of time. Conda has had many releases since 2012. You can quite easily install it with the shell script, so even a scientist that doesn't know how to use a terminal can do this. It has self-update support, and it basically has very little dependencies. It just chips with whatever it needs. You don't need sudo for installing or using Conda, so that's important as well. EasyBuild has been released since 2012. Before being developed in-house for 3 years. It has a bootstrap script to install it, or you can just pip install EasyBuild. It has self-update support, and it really relies on having environment modules there. It doesn't work without environment modules, so you need this. You need to have Python, you need setup tools today, and to get started you need a C++ compiler on your system as well. Here's also here, no sudo for installation or using of EasyBuild. So normal users can install software without asking admins. Nix has been around for a very long time, since 2004. Stable since 2012, so 1.0. It has a install script to install the binary release, or if you want to, you can build Nix from source. You have to get this build daemon running, because this is the thing that actually does the installations. And this needs to run as root. So here you do need sudo to install Nix, not to run it. A normal user can talk to Nix and get stuff installed, and the installation is just done by the daemon, so the user is talking to the daemon. Self-update support is there as well, and dependencies, well, not really, unless you want to build it from source, then the stuff it needs has to be there. Geeks, so Geeks is more recent than Nix. It's no 1.0 yet, so still in beta. But it does a lot of the stuff that Nix does too. That says actually not true anymore. It says no installation script available. They fixed that thanks to seeing the draft of my talk. So that triggered that. That's good. Self-update support, and it has some minimal dependencies. And then SPAC, a handful of releases. Well, yeah, since 2014, not stable yet. The installation here is a little bit different. You just git clone the GitHub repository, and then you can get going straight away. So you don't need to really install it, which is why I gave this a lower rating, because it feels a bit off. Certainly, if you give this to a scientist, they're like, what is this Git thing? And it feels a bit off to me. I know Todd disagrees here. But to update Spack, you just do git pull. You pull in updates from the GitHub repository and some basic dependencies. So documentation, comparing the documentation, all of these have really good documentation. I gave EasyBuild the lowest rating here because I know where the gaps are in the documentation that have to be filled in. I'm sure there are gaps for the others as well, but I can't tell as an outsider. So try to make this fair here. So configuration, so once you get the thing installed, you need to maybe configure it. With conda, there's basically no configuration at all. You just tap and that's it. That's very good. With EasyBuild, you really have to do some configuration. The out-of-the-box defaults don't make sense for most people, but we can't come up with a better default, or at least I don't see a way. You really need to tell it some things before it can get going. Geeks and Nix, I gave these a lower rating mainly because of the daemon that you have to get running as user, as root, and you need to create build users, so realize them to the build users with different permissions, and also because both of these are locked to a specific location for the software. So GNU Store and Nix Store, you can change it, but you're going to suffer if you change it, so typically people don't. And then Spack has very little configuration that you really need to do, but if you want to, you get a lot of options, so that's very good. Basic usage. Conda is very straightforward. You install something, you do this source activate of a script, and then it's ready to go. This is creating the environment, and this is the actual installation. You can easily install other software versions and build packages yourself if you really have to. So in terms of basic usage, I'm not making any distinction. Everybody's getting 3 stars because it depends on what you want to do. With EasyBuild, you search, you get this easy config file that you can use. You do --robot to make it install the dependencies, and then you can load the module. Installing other software versions is just changing easy configs, or maybe writing some Python code yourself. Depends. With Nix, very similar. You can search for what it has. Nix ends to install things. It links it in your profile. It's ready to go. Or if you really want to, you can build your own software or software versions. Geeks is pretty much the same, just different commands. And then Spack, you get all this flexibility of juggling dependencies and all that stuff. And you can do Spack load, or you can load the modules that it generates. To install different software versions, you don't even have to dive into the Python yourself. You can just tell it to install a new version, and it will go and do what it can to make that happen. Time to result, so how long does it take to install software with these tools? Well, the things that do binary packages by default are very fast, seconds. While with Spack and EasyBuild, you're building from source, so that's a big difference. And with EasyBuild, you have to build the compiler typically first before you can get to the software. With Spack, you can pick up the compiler in your OS. So these are seconds to install this FFTW. With EasyBuild and Spack, it will take like an hour depending on whether you're going to pick up the system compiler with Spack or not. Performance, I'll speed up a little bit here because I'm running out of time and basically want to get to this slide. So this is performance of an FFTW library with the 5 tools. This is seconds, so lower is better. You see if you do binary packages, you install these are generically built. So you're not really using the hardware very well in this setup. Spack and EasyBuild compile from source, so these can do a lot better. They can target the hardware. Today, Spack doesn't do this out of the box, so, which is why it's pretty much at the same level as the binary ones. It builds generically by default, but you can easily tell it to do different. EasyBuild really targets the hardware you are on, so that's why it's getting better performance. Now, I'm sorry, Todd, for this, but when I was testing this, I ran into an issue with Spack. So Spack was, because of a bug, was building with -0, so it was quite slow. This was fixed in hours by Todd, and it was a quick release. They were just not aware of this, but it was something I ran into while testing. So this is definitely not the norm for Spack, don't get me wrong. A lot of stuff we didn't cover. I won't go into this too much. Each of these have their key features that are very important. So definitely take a look and try to deep dive into all of these before you make a selection. Well, this is the summary of the table. So who won? Well, it depends. It depends on what you want to do. It depends on who you are. It depends on how much experience you have yourself, whether you're, who of these three you are. It really depends on the use case, your experience, your profile, what you actually want to do. Do you care about performance or quick installations and so on? And then one cool thing was this talk, because I sent a draft to a lot of people, it started making waves and stuff happened before I did actually the talk. So SPAC had a bug fix release because I ran into the 0 issue. That was fixed in hours, so that was really good. And I figured I was doing something wrong, and it turned out I found a bug in a different project, so that was cool. And it was fixed really quickly. There's an easy installation script for geeks now. It was sort of there, but not very clean. And they finished it because I was complaining about the installation, which was very manual, so that's good. And there's a very good blog post by Ludovic, who's giving a talk later today as well, on the performance aspect of geeks and basically the possibilities they have to get rid of this performance issue. Definitely read the blog post. It's very good. It has a lot of technical references to all the things you can do. Other build tools, which I'm not going to cover here. I didn't cover most of these because they have a lot less focus on scientific software. So I haven't seen people using these on supercomputers to install software for other people. And I didn't cover Singularity and UDocker, so these container things for HPC, which is now happening as well. But if you're interested in that, you should definitely take a look at these two projects, especially Singularity. That's it. Any questions? Yes. Oh, wait, you should take the mic for the questions. Where's the mic?
I think it's okay.
If you can,
It's for the recording, so you should take the mic.
you can repeat.
Oh, yeah, or I can repeat the question. Go ahead.
Can you go to the performance slide? Then you tell about the performance of all these systems.
The performance slide. I'll take the one without the red bar to keep it fair.
And for the EasyBuild, you have also mentioned about the AVX and AVX2 instructions.
Yes.
So did conda and all those.
These are not using AVX, which is why they're getting bad performance. They build generic packages so that you can install them on non-AVX hardware.
And also SPAC. Does it also use
SPAC because it doesn't do it by default, but you can tell it to. Because here you're compiling from source, so you can actually tell it to target your hardware, and then it will generate AVX, and it will be at the same level as EasyBuild. It just doesn't do it out of the box. So I was showing you what you get by default. It basically has a warning slide, like be careful. You can do a lot better with SPAC very easily, but you need to be aware maybe if you're just assuming it's not going to happen. Yeah, and for this aspect, you should read Ludovic's blog post, because there are ways to get around this. You can still ship binary packages and get good performance. They're just not there yet. It's not happening right now, but you can.
and EasyBuild will update whenever you do AVX instructions?
Sorry, EasyBuild?
Every year or so, not year or so, but couple of years, new AVX instructions are.
Right, so if there's new, like Intel Skylake has AVX 512, we don't really need to change EasyBuild for this because the compiler does it. We just tell the compiler build for this thing. And if the compiler can do it, then it's fine.
The only difference here is that EasyBuild passes the with AVX argument to configure.
Yeah, so EasyBuild is just telling FFCW build for AVX by default. That's the only difference. You can do the same thing with SPAC. Here, it's harder because you have to rebuild the packages, which is, let's say, not that common, or certainly in the geeks thing, but yeah, Ludovic and you should talk offline with Ludovic about this because they really know how to fix this, but it's not there yet today. All right. Olaf.
I'm missing the dimensions, distributions like Debian or CentOS and architecture, CPU architecture. Could you please comment on that?
So why didn't I cover Debian?
Well, whether there are some dependencies on that. So only supporting,
Only supporting certain Linux distributions?
Yeah.
That's not really there. I mean, the things that work for basically any.
Points like Kerberos, I think if you like to integrate with that.
There's certainly details there, yeah, but in general, it should work on any Linux distro, each of these tools.
Architectural ones.
You mean
CPU.
CPU, right? Okay, so I know of some people using EasyBuild on ARM, for example. I don't know about SPAC. SPAC has good support on ARM and Power.
Oak Ridge built 200 packages in stack
Yeah.
before computing.
The one this was on Power?
ARM.
ARM. So Oak Ridge has been using SPAC on ARM. That works out really well. This is mostly, so it's Python. So Python runs anywhere. As long as you have a compiler that...
Are there fine points that some modules are not available?
There are some details, yeah, but as long as your compiler can handle your architecture, you're fine.
What's the, I mean,
No, sorry, that's not really true. Okay.
No, well, if you disagree, we can talk about this, but on a high level, shouldn't be an issue.
High level, yeah.
There's certainly detail. If you try EasyBuild or SPAC out of the box on something sexy like ARM or the new Power, you may see more issues than on x86. That's true. But in principle, it should work, and it's just,
Yeah, in principle.
yeah. All right,
I mean, spec does work on ARM, so,
yeah.
yeah.
Yeah, last question. Yeah.
I don't really get the point. The idea is I install one of these packet managers
Yeah.
as admin and I'm out of the game.
Not necessarily as admin. For many of these, the user can do it themselves.
In spec, you just clone it in your home directory.
Yeah. For most of these, and once also for Nix and Geeks, once the admin has provided Nix on the system and Geeks, users can install their own software.
So it's not an admin topic. No, the user should go here and
Not necessarily. It can be for users.
yes,
It's also for admins to install software for the users because they don't know how to do it.
yes, these are different topics. So that is,
Yeah.
if I as admin has to install every package, I'm in the business. If I say here's your conda tool, do it yourself.
You can do a combination of both.
For example, I tried conda, installed conda read only. You can do with last version.
Yeah.
And some user started and he got an upgrade message. You can upgrade your conda, but he can't.
He
He's not
can't.
allowed.
Yeah.
So
Yeah.
it's installed as another user.
And I think Conda is a bad fit for providing software to other people. You wouldn't use it for that. Users would use it themselves. The other tools like SPAC and EasyBuild are more targeted
There
towards.
is no bootstrap. You have to download some shell script code.
Yeah. Yeah.
Type it into. That's something you don't want to do. Your users copy and pasting website code.
Yeah, but they will do it anyway, and they
I know.
and they don't need permission, so you cannot
Permissions.
avoid them.
Advice is don't copy paste weird website code into your shell.
Sure.
So you can't say please do it if you want to install mini conda.
Some people tell their users to use Conda.
They find out very, very fast. So I want to
I know.
pre-install conda and say use this one.
Yeah.
But that doesn't work.
There's-
because of, you need a cron job in background. Always.
There's all kinds of details there. Well, also for the generic aspect. So with Geeks and Neeks, there's a way out. With Conda, I'm not sure there's a way out to
But
fix the
if I
performance
install
issue.
packages that needs root requirements, and I run on a read-only cluster, it doesn't work either.
No.
So I can
That's true.
install until I
But with Conda, users can install anywhere. They can install in /tmp, and they can install in their home directory.
Sorry to interrupt you. Can you
Yeah,
take
we
that
should wrap
offline,
up. We should
please,
take
so
it
we can
outside.
go on.
Good idea.
Thank you.
Thanks, everybody.